All right, well, moving along, I want to make sure we fit everyone in. Next up is Evan Wu, who will be introduced by Casey Dedham.
Casey, you're muted.
Okay.
Oh, yeah. Casey, are you able to introduce Evan?
Can you hear me now?
Yes.
Okay, sorry. Our NASA computers do not always cooperate with Zoom. So hi everyone. I'm Casey Denham. I work at NASA Langley Research Center. So although I come from the aircraft side of the house, my larger organization works a lot on mission, conceptual design, and analysis. So I had the really great opportunity to work with Evan to kind of introduce him to the conceptual design process for missions and let him explore that process with the mission that he's worked on previously and get to add a little bit more detail to it. So on to Evan.
Good afternoon, everyone. I am Evan Wu, and today I'm presenting Project Aether. And so this is a bold mission concept that sends a pressurized airship to Europa's surface, and it can assess whether one day humans could adapt and live there, just in case the Earth becomes inhabitable. So some conceptual process takeaways I've had is greatly focused on mission identification. Before I developed this mission, I did several research processes, and this was inspired by the Havoc mission that was sent to Venus. And so Aether uses a solar-powered helium-ammonia-filled atmospheric airship. Its design allows it to float in Europa's very thin atmosphere to withstand extreme cold and a lot of radiation. So the airship is powered by solar cells, which recharges during long Europa days. Storing power in hardened batteries to survive nights or shadows is also one thing to consider. The gondola is radiation hardened and pressure sealed to house science instruments and avionics. Hovering using an ion propulsion and EM-assisted lift, it glides smoothly along Europa's surface. It can also lower retractable stilts to anchor into Europa's icy terrain, either using laser drills or hot screws to dig into ice and harvest bacteria. Now the location here is Europa, of course, one of the one of the Jupiter's four moons. Our destination is believed to harbor a subsurface ocean underneath the icy crust. So this Aether airship will operate 500 meters or less above the surface to focus on chaos terrains and plume zones such as Thera and Thras Macula. Those usually dig deeper into the ocean, so there's a higher chance to find biosignatures there. Environmental conditions is brutal. Okay, so temperatures get as low as negative 160 C, 13.4% only gravity of Earth, and so the atmosphere is practically a vacuum. And so the worst thing here is that radiation levels can go up to 5.4 sieverts per day. And so we need to adhere to these specific environmental requests to keep the mission hovering so that the airship doesn't implode. Now, our mission objectives, so for science, are to search for signs of life, study the thin atmosphere, and explore subsurface ocean interactions with surface. We use onboard instruments to analyze ice chemistry, gases like oxygen and water vapor to look for bio or geology to indicate habitability and possibly match it up with human DNA. From an engineering standpoint, Aether tests materials that resist radiation or cold. It also demonstrates precision hovering, autonomous hazard detection, and anchoring ice ability. So most important, it'll send back very detailed environmental data for designing future crewed habitats in Europa. And so our times and projection dates would take around 12 years and 2 months because we don't have the necessary precautions to assign the airship to those specifics yet. But here are the times and projection dates I'm approximately speaking. So data collection will take 2 years and everything else will be just following what our future mission plans will be. Our additional components include a life signal transmitter to detect potential biosignatures and anomalies, such as oxygen adaptive bacteria, key point here. So placed right under the gondola, it would send vital findings to Earth to boost our chances to identify habitability. Our propulsion engines there are four of them, two per side, designed to control lift, hover, and thrust both forward and backward to prevent data loss. And so they're optimized for Europa's low gravity, low pressure atmosphere. Internal power storage and connectors ensure sustained efficient lift. Our engineering requirements must resist brittleness at negative 160 C with healing polymers, radiation shielding, and then reliable energy even in Jupiter's shadow. Ice drilling payloads, redundancy, and backup power sources will be integrated here. Environmental requirements. Okay, so Europa's trace atmosphere means traditional lift will not work, so we need ion hover tech. Magnetospheric storms and long eclipses could also derail, and so communication is delayed, so it must operate with autonomously. So to send bulk data back to Earth or relay orbiters, or any one of them. Here's where it starts getting serious. Mission risks can range from major to minor. So this is categorized on a 5 by 5 matrix. So the biggest dangers here would include such as ruptures, destabilization from geysers, or full data loss during comm failures. And now the worst one of all is a massive Joviation radiation storm, frying all electronics, destroying all memory, and killing all communication. And also, it could just snap the airship in half. Understanding these extremes provides countermeasure opportunities for us. So, solutions to all risks. So, from self-healing materials to plume avoidance satellites, we have AI-powered protection and dual communication channels. With that, Aether will be ready to operate. This mission is purely about resilience, intelligence, and hope. Emergency precautions include dual battery banks, autonomous stress beacons, and rapid attitude capabilities. So the gondola seals during breaches while nanofilm repairs micro tears. AI later scans hazards up to 5 kilometers away, and so radiation dampeners would protect the electronics. So in emergencies, a hardened data pod ejects. Backup store critical data and hydraulic overrides would free the anchors so the mission does not fail. This is a very unlikely kind of finding, but if somehow the biosignature detector works just as it is, we could, similar to Mars, build some kind of a space station to either harvest plants or extract oxygen samples. And so I would just like to take the time to thank Dr. Denham for guiding me through everything. She helped me tweak the slideshow just so it can be more feasible, right? And so with that, I learned new things about mission development. She helped me find sources, and overall, I would say this is probably one of the most meaningful steps to get started. If you want to be a future engineer, then something like this could be a first step. Any questions?
Oh, wow. Let's really thank Evan for that incredibly detailed presentation. I feel like we could just build that right now and go.
With amazing images as well.
Naomi, yes.
Yeah.
So, what is the plot you have in mind for the ion thrusters? Is it xenon or something else?
For the thrusters, for the propulsion engines, you mean?
Yeah.
Those are just ion powered.
Um, Ion
Probably
thrusters work by ionizing you typically a noble gas, but it does require propellant.
I would say probably xenon because it's more powerful.
Mhm. Um, just an idea on that point. You didn't really say how much you know about Europa's atmosphere, but since it's going to be in atmosphere, you could if you boost the electricity going to ionizing, you could also vent in Europa's atmosphere to use as a propellant.
Thank you for the
Do you
advice.
have any kind of estimates on like mission cost or time?
I'm not exactly sure, but around 1 pound of Kevlar is gonna cost us like $47. So in a ballpark sense, I'd say this mission would about to take around maybe 300 grand or something.
Thank you.
You're probably off by many orders of magnitude because nothing in space is that cheap.
Yeah.
300 million would be more like it.
Maybe with the advancement in technology, they can be decreased in price.
Okay, well, we're all hoping for that because we'd love to go check out Europa. But I think we need to move on because we're way past time now.
Yeah.
Nathan,
All right, one one more question quickly, and then we'll go on to Naomi.
Yeah, quick question. So, have you ever thought about like potentially like also like the spacecraft communicating with the Europa Clipper who's also like orbiting, was like studying Europa? Like it's like similar to Mars where they got rovers and they got like satellites in orbit. Like they can send more data to Earth. Have you thought about like maybe communicating between the two spacecraft? That could be like a lot more efficient and work
yes.
together because the Europa Clipper is also just measuring stuff up there.
Yes, so relay drones will potentially solve that problem for us.
Okay.
All right. All right, great. So I want to make sure Naomi gets time for their presentation.